Okay, so I got a couple messages from students who had questions on reactions. Some of the things we didn't cover in the review session, so I'm going to make a quick video of this and send it to you guys. One is types of reactions. So let's go through that step by step. Number one. One type of reaction looks like this. Let's say we have aqueous lead 2 nitrate reacts with aqueous sodium chloride. Let's write the molecular reaction, the total ionic, and the net ionic. So first thing we should do is figure out what the heck lead 2 nitrate is. So that's using your naming rules. Whenever you write a formula from a name, you look at charge. They tell you the charge of lead. The lead is a +2. Nitrate is something you have to know. So to put that together, you balance the charge. 2 minuses for every 2 plus, so 2 nitrates. It's aqueous. Reacting that with sodium chloride. So, from the periodic table, sodium is +1, right? Chloride is -1. So those go right together. Now, notice I wrote the ions on top here. This is going to help you, because when you predict the products, you have to predict the formulas. And when you write a formula, you always look at charge. So let's switch them around. Remember, positive goes with negative. Opposite charges attract each other. So, PbCl2, because the 2 and the -1, right? And the Na and NO3. Make sure you write the positive one first. Then you check the solubility rules. So once you look at the solubility rules, you'll see that sodium and nitrate are both soluble, so always soluble. We also notice that this is the insoluble one. That's the solid. That's the precipitate. Okay, so the next thing we need to do is balance it. Let's see, there's 2 nitrates. So let's put a 2 here. But that also makes 2 sodium. Let's put a 2 there. And now it's balanced. So this is the balanced molecular equation. Let's get the total, or sometimes called complete ionic equation. Here's what you do. Anything that says AQ means dissolved. It means you break it up. Break it up into the individual ions. Well, what individual ions are there? All this stuff we saw before. So it must mean this breaks up into Pb and 2 nitrates. Right? The little subscript 2 there means there's 2 nitrates. All dissolved. Watch out for this 2. This is 2 sodiums plus 2 chlorides. Once again, anything that's AQ, we're going to break it up. But that's not AQ. That's solid. You leave solids alone. That's like a rock sitting at the bottom. This is dissolved. 2 Na plus plus 2 NO3 minus. Okay. There's your total ionic. Anything that says AQ, you break it up. Anything that says solid, you leave it alone. Okay. So, to get the net ionic, you look for spectator ions. Look for the ions that are the same on both sides. Those are the same on both sides. Those are the same on both sides. Now make sure they're exactly the same. So taking those out, we have this. And that is your net ionic equation. Okay, now let's go over the type of reactions now. This type of reaction that we saw right here is a double displacement, sometimes called double replacement. Not too sure what your teacher calls it. You can see that because there's 2 compounds that and the ions replace each other. If there's 2 compounds and the ions replace each other, it's a double replacement. Let's talk about this one. In this case, we have a single element replacing another element. This is a single, oops, not single, single replacement. Sometimes called single displacement. Not too sure what your teacher calls it. Okay, be careful on these, because whenever you make a compound, always look at charge. So let's take this for instance. So if the sodium kicks out the aluminum, the sodium must form with the chloride. But once again, look at charge. Sodium is a +1, and chloride is a -1. So it's actually NaCl. It's not NaCl3. This is +1, this is -1. The aluminum now becomes an element by itself. You may be thinking, wait a second, it's not balanced. That should be Cl3, but just balance it. Now we have 3 and 3, and we're done. So that's a single replacement. Another category is combustion. You know it's a combustion because there's some sort of CH something. It could have oxygen, it may not have oxygen, but C always has carbon and hydrogen, some sort of hydrocarbon. Always requires oxygen. What's required to burn something? Oxygen. Always forms carbon dioxide and water. So these always stay in the reaction. The only difference is how you balance it. So for instance, for let's say C3H8, 3 carbons, 8 hydrogen makes 4. So 6 plus 4 is 10. So there you go. There's just one example of a combustion reaction. Okay. Let's talk about the next one. Some books call this synthesis, some books call it combination, but basically means exactly that. You're combining things together. So an example of that would be like this. If I combine those together, I form sodium chloride. But once again, watch out for charge. +1, -1. And you just balance it like this. So combining things together is combination. Okay? Breaking them up is the opposite, which is decomposition. So to decompose something, you usually have to heat it. An example of that would be calcium carbonate. If you heat calcium carbonate up, you get calcium oxide and carbon dioxide gas. Whenever one thing is breaking down into more than one thing, it's always decomposition. Okay, so let's see if we covered it all. There's 5 classes: single replacement, double replacement, single replacement, combustion, synthesis, decomposition. That's it. Okay, so hopefully this helps. Remember, when you do this, make sure you're good on names. Being able to go from name to formula, look at charge. Predict the formulas. Switch around the ions to predict the products. Balance it. That's the balanced molecular equation, which is a double replacement or double displacement. Whatever's AQ, you break it up into the ions. Whatever's solid, remain the same. AQ, break it up into ions. Whatever's the same on both sides are spectator ions. Get rid of those. And then you have your net ionic. So this is balanced molecular, complete ionic or total ionic, net ionic. Okay, good luck.